DSPy's BestOfN module implements a fault-tolerant prediction strategy by orchestrating multiple language model executions with distinct rollout identifiers, enabling probabilistic bypass of cached or suboptimal responses. This mechanism employs a reward-based selection protocol to surface the highest quality output meeting predefined acceptability thresholds. We are about to examine how the fail count parameter modifies this retry behavior, specifically configuring the system to terminate after the first encountered failure rather than exhausting all attempts.
Best of 3 equals DSPy, BestOfN. Module equals Ka. N equals 3. Reward FN equals one-word answer. Threshold equals 1, 0. Fail count equals 1. Best of 3 question equals, what is the capital of Belgium? Hash raises an error after the first failure.
This code demonstrates how BestOfN handles failures using the fail count parameter. The BestOfN module runs the provided module multiple times up to n equals 3 with different rollout IDs, stopping early if the reward FN returns a value above the threshold equals 1, 0. By default, it continues through all attempts even if errors occur, but setting fail count equals 1 makes it raise an error after the first failure instead of continuing. The fail count parameter provides control over error handling behavior, allowing you to balance between resilience and early failure detection. When fail count equals 1, the system fails fast, which is useful for debugging or when you want to immediately know if something goes wrong. Without this parameter, BestOfN would attempt all n iterations regardless of errors, which might be preferable when you want maximum chances of success despite intermittent failures. This trade-off between fault tolerance and early termination is crucial in production systems where you need to decide between retrying potentially recoverable errors and failing fast to alert operators. Let's break it down.
Best of 3 equals DSPy, BestOfN.
Creates a BestOfN instance named BestOf from the DSPy framework. This module is designed to run a provided module multiple times up to a specified n with different rollout IDs, returning either the first prediction that meets a threshold or the one with the highest reward if none meet the threshold. The specific configuration parameters for this instance are not visible in this line.
Module equals Ka.
Assigns the string value Ka to a variable named module. This creates a simple identifier that likely represents a module name or category within the DSPy framework context, though the specific usage isn't visible in this single line. The assignment itself is straightforward. It's just storing a literal string value in a variable for potential later reference.
N equals 3.
Sets the variable n to the integer value 3. This likely configures the number of attempts for a BestOfN module, where the system will make up to 3 calls to improve prediction reliability.
Reward FN equals one-word answer.
Assigns one-word answer as the reward function that evaluates whether a prediction meets the quality threshold for the BestOfN module. This function determines if a generated answer is valid based on the criterion of being a single word.
Threshold equals 1, 0.
Sets a threshold value of 1 for the BestOfN module, which determines the minimum reward score required for a prediction to be accepted without further attempts.
Fail count equals 1.
Initializes a variable named fail count with the integer value 1, which will control how many failures are tolerated before stopping in a BestOfN module.
Best of 3 question equals, what is the capital of Belgium?
Calls the BestOf function with a question parameter set to what is the capital of Belgium. This will execute the underlying module up to 3 times with different rollout IDs, returning either the first prediction that meets a threshold or the one with the highest reward if none meet it. DSPy's BestOfN module orchestrates multiple LM executions with distinct rollout IDs to bypass caching and surface high-quality predictions through reward-based selection. The configuration here demonstrates a deliberate trade-off between fault tolerance and early failure detection. By setting n equals 3, the system attempts up to 3 predictions, while reward fn equals 1 word answer and threshold equals 1, 0 enforce strict quality criteria for acceptance. The critical design choice is fail count equals 1, which shifts the behavior from resilient retry to fail fast mode, terminating after the first failure instead of exhausting all attempts. This configuration prioritizes immediate error visibility over maximum success probability, making it ideal for debugging or scenarios where early failure detection is more valuable than persistent retries. The components work together to balance prediction reliability with operational control, letting you tune the system's response to failures based on your specific needs.
The refined module juggles failures until one slips through the threshold's fingers.